Hey everyone, and welcome. So glad you're here. If you've got a Java interview on the horizon, well, you've landed in the perfect spot. We're about to do a quick fire prep session on the core concepts you absolutely, positively have to know.
Okay, let's just get it out there. That pre-interview stress, that tension, it's totally real, right? But hey, don't you worry. Today, we're going to tackle some of the most common questions head-on so you can walk into that interview feeling confident and ready. You with me? Let's do this.
So every interview has to start somewhere, and more often than not, it's with this classic icebreaker. It seems so simple, but trust me, nailing your answer here really sets the tone for everything that follows.
So, they ask, what is Java? A great answer is short, sweet, and hits the big keywords. You want to say it's a high-level and platform-independent language. Now, high-level, that just means it's written in a way that's easy for us humans to read and understand. But the real game changer, the phrase you really want to lean into, is platform independent. Let's break down what that actually means.
And this brings us right to Java's legendary slogan, its killer feature: write once, run anywhere. Seriously, this isn't just some catchy marketing phrase. It's the entire philosophy behind the language. So how on earth does Java pull off this magic trick?
The secret sauce, the magic box, is the Java Virtual Machine, or what we all call the JVM. The best way to think about the JVM is as a universal translator. See, every operating system, whether it's Windows, Mac, or Linux, gets its own special JVM. This is huge, because it means you don't write your code for a specific computer. You write it just once for the JVM, and the JVM handles all the translating for you.
And here's how that whole process plays out. You write your Java code, then the compiler takes it and turns it into a special intermediate language called bytecode. Now, this bytecode file is architecture neutral, meaning it doesn't belong to any one system. It needs the JVM on a machine to read it, interpret it, and then translate it into instructions that specific computer, be it a Mac or a PC, can finally understand and run.
So, what's the bottom line here? It means that one single bytecode file can be sent to servers, desktops, mobile phones, literally anywhere a JVM is installed, and it'll just work. That is the power of write once, run anywhere, and it's a huge reason why Java became so dominant.
All right, let's move on to the next massive topic. If the JVM is kind of like Java's brain, then object-oriented programming, or OOP, is its heart. I can almost guarantee an interviewer is going to ask you about these 4 fundamental pillars.
First up, encapsulation. The key word to remember here is hiding or protecting. You're basically bundling your data and the code that works on that data all together into one neat little package. The slide says it perfectly. Think of a medicine capsule. The plastic shell protects what's inside. In programming, this is so important because it stops other parts of your application from accidentally messing with data they have no business touching. It's all about control and security.
Next, we have abstraction. This is all about hiding complexity and only showing what's necessary. A perfect real-world example is the accelerator pedal in your car. You just press it and the car goes faster. You don't need to know anything about the engine, the fuel injection, or any of that complex stuff under the hood. Abstraction in code does the same thing. It lets us use powerful tools without needing to understand every single detail of how they work. Pillar number 3 is inheritance. Now this one is super intuitive because it's just like real life. A child inherits traits from their parents, right? Same idea in Java. A child class can inherit all the properties and methods from a parent class. And why is this so brilliant? Code reusability. It means you're not starting from scratch every time. You can build on top of code that's already written and tested. It's just smart, efficient programming. And finally, the 4th pillar, polymorphism. I know it's a big word, but the name gives it away. Poly means many, and morph means forms. So it's the ability for something to take on many forms. For example, imagine you have a draw command. If you give that command to a circle object, it draws a circle. But give that exact same command to a square object and it draws a square. It's one action that results in different behaviors, which makes your code incredibly flexible. Okay, so we've talked about how Java works and how it's structured, but things don't always go according to plan. What happens when things go wrong? Let's talk about every program's ouch moment, handling exceptions. So what is an exception? Simply put, it's an unexpected problem that pops up while your program is running. Maybe it can't find a file it needs or the network connection drops. Instead of just crashing and burning, Java's exception handling gives you a way to deal with these problems gracefully. Now, interviewers love to ask about the 2 main types. First, you have checked exceptions. Think of these as external problems that are kind of outside your control.
like a file not being there. The cool thing is, the Java compiler actually forces you to think about these and write code to handle them. Then you have runtime exceptions. These are usually our fault, bugs in the code. Think trying to divide a number by 0. The compiler doesn't catch these, and they only show up when you're actually running the program. Knowing this difference is a huge deal.
And there you have it. We've just blasted through some of the most critical topics you're going to face. So let's do one final, super quick review to make sure you are totally ready for that interview.
So let's lock this in. What did we crack today? 1. Java's write once run everywhere superpower comes from the JVM. 2. The 4 pillars of OOP are encapsulation, abstraction, inheritance, and polymorphism. Know what each one is for. And 3. Checked exceptions are for external problems the compiler warns you about, while runtime exceptions are usually programming mistakes that sneak up on you later. You've got this.
You're prepped, you know the what and the how. So the only question left is the why. After you absolutely ace this interview, what incredible problem, what amazing application are you going to go out there and build with the power of Java?
Thanks for joining me.